we look at the solution now when the applied force is increased, and we want to see how can we calculate the acceleration. Now, the first mark will be awarded to the formula. You can write the formula like this or like this, then it will be awarded a mark. Why is the F for the friction and tension put in brackets and added? This is because they are going in the same direction, and that direction is opposing the motion. That's why you will see in the next step, they are both negative. Now, that is your substitution. You get 1 mark for the formula, and then you get 2 marks for the substitution. The other mark is substituting on the right-hand side, writing 8A, indicating that you're working with the 8 kg block, and the other mark is for your left side substitution. So that was the 8 kg block substitution, and now we go to the 2 kg block. For the 2 kg block, you cannot get the mark again for the formula because the mark was awarded earlier. Then here you'll be awarded a mark for your substitution of the 2, which is the mass, and the 9,8. And then from there, you equate the 2 equations, and then you eventually get your answer. So that is basically how we can get the acceleration. Once you get your acceleration, you can substitute your acceleration in one of the 2 formulas. If you substitute in the first formula, you get 23,68, or you can substitute in the second formula where you get 23,68 again. So that is how we can work out the Newton's laws equations. The question 3 is based on the following. The definitions that are important here is free fall and projectile. Free fall and projectile are very, very, very important for you to get the marks in question 3. You must be able to define free fall. You must be able to define projectile motion. When defining free fall, remember all the definitions will refer to the examination guideline 2021. Free fall, just pay attention, it will talk to the motion of an object under the influence of gravitational force only. But when defining projectile, it's almost similar but different. When defining projectile, it talks to the object that falls under the influence of gravitational force only. We have seen learners swapping them when they define in the final examination. Just pay attention that you do not swap them. Now, magnitude and direction of the acceleration is very important. You need to know that your acceleration is always downwards and is always 9,8 meters per second squared for all objects under free fall. Now, you will get your hot air balloons that are not under free fall, but the 9,8 meters per second squared applies for all objects that are under free fall, with only gravitational force acting on them. Now, whether your object under free fall is going upwards or downwards, the gravitational acceleration is always downwards and is always 9,8 meters per second squared. Even if your object goes to a maximum height, at the maximum height, we know that the velocity is 0. Even when the velocity is 0 here, the gravitational acceleration is still 9,8 meters per second squared. So your gravitational acceleration is 9,8 meters per second squared while the object is going up. It is also 9,8 meters per second squared while the object is going down. It is also 9,8 meters per second squared at the maximum height where the velocity is 0. The equations that are important for your projectile motion are listed here. These equations are very important and they are obtained on your data sheet. No need to memorize them. What is important is to know the meaning of each symbol. The VI is for the initial velocity, Vf for the final velocity, delta x for the displacement, A for the acceleration, which is the gravitational acceleration in this case, and delta t is your time interval. Remember, velocity is a vector quantity, therefore it has magnitude and direction. Final velocity, vector quantity, magnitude and direction. And then your displacement is a vector quantity, magnitude and direction, acceleration, magnitude and direction, and your time is a scalar quantity. Therefore, even when you do your calculations, you should never get to a point where you get a negative time. Your time should be positive at all times. Now, for your hot air balloons that are moving at a constant velocity, just remember to use the formula delta x is equal to vi delta t. Where do we get that formula? We have the formula delta y or delta x is equals to vi delta t plus half a delta t squared. But now, moving at a constant velocity means that the acceleration is 0. So if we substitute 0 there, we are left with delta x is equals to vi delta t. So you can use this formula for constant velocity, or you can use it as it is, but remember to substitute the 0 if you are told that the object is moving at a constant velocity. Now, choosing direction, the most important part of this topic. Let's look at if upwards is taken as positive. If upwards is taken as positive, this is very important. Remember, our G is always going downwards. And then if you take upwards as positive, then our G will have a negative value. So it will be negative 9.8 meters per second squared. Now, if upwards is taken as positive, your velocity becomes positive if your initial velocity, your final velocity becomes positive if that object is going upwards. And it becomes negative if that object is going downwards. Remember, we took upwards as positive. So anything that goes upwards is positive, anything that goes downwards is negative. Your height above the starting point have a positive sign because it went upwards. Your height below the starting point gets a negative sign because it went downwards. Anything that goes upwards becomes positive, anything that goes downwards becomes negative because you chose upwards as positive. The time interval must always be positive. Remember, time is a scalar quantity. Now, if you choose downwards as positive, your G is always going downwards, therefore it will have a positive sign. If the object starts with a velocity that goes upwards, then it must have a negative sign. If your velocity of the object is going downwards, then it will have a positive sign. Remember, you took downwards as positive. Then your height above the starting points will have a negative sign because you chose downwards as positive. And your height below the starting point will have the positive sign because you chose downwards as positive. Again, the time interval is always positive. Time is a scalar quantity. Should you calculate your time and get a negative answer, you need to go back and check where the error is, because time cannot be negative. Now, in this topic, there are graphs that are assessed. Let's look at your position versus time graph. Your position versus time graph must always be a curve. Make sure that the position versus time graph is always a curve. And another thing that is very important is your zero position. Now, let's look at the first graph here. This graph takes the top of the building, the ground, as there's zero reference. So if the ground is a zero reference, your graph will start from the top of a building and it will go there. So this now becomes your ground. Now, if the top of a building is a zero reference frame, that's your zero, then from the top of a building you go up, then you go down. So just know that as the graph curves like this, the object is going up, and then as the graph curves like this, the object is going down. So when you have a graph that goes like this, so this simply means that the first part, the object was going up, and then in the second part, the object was going down. Very important. The velocity versus time graph, just remember that this must be a straight line. And if it's a straight line like that, you need to know this point. So usually this point is the maximum height. So the point where the graph touches the x-axis, that is the maximum height. And this point now is the initial velocity. So point A indicates the initial velocity, which is the VI. And then this point here, velocity is 0, that is the maximum height. And this one becomes your final velocity. The same with here, with the second graph. This is your initial velocity. This is maximum height, and that is your final velocity. So that is just a reminder about your graphs. Your position versus time is a curve, and your velocity versus time is a straight line. We want to carry on. Now, what are the definite marks in question 3? The definitions that are very, very important is defining free fall. We have talked about it earlier. So the question paper will ask you to define free fall or projectile. And for that, you get 1 mark. The formula to calculate time, you get 1 mark. The formula to calculate velocity, 1 mark from all the 4 formulas. Displacement, 1 mark. Drawing a graph or interpreting a graph, the definite mark is 1 mark. So here we have a total of 6 marks, which are definite marks. So no learner should get less than 6 marks in projectile motion. The questions, let's look at the question in projectile motion. A ball is thrown vertically upwards. So we are told the ball is thrown vertically upwards. Remember, we need to choose direction. With velocity v from the edge of the roof, this roof, we are told, is 40 meters tall building. It takes 1.53 seconds to reach a maximum height. So the 1.53, it's very important for you to tell it's from where to where. So 1.53, the delta t of 1.53, it's from the point where it is launched to the maximum height. So it cannot be used anywhere else. It can only be used from the point where it is launched and only to the maximum height. So there's the definition. Define the term free fall. Motion of an object under the influence of gravitational force only. The magnitude of the initial velocity of the ball, then you need to choose an equation after choosing direction. We can take upwards as positive. Then you can choose your formula. Maybe you can choose VF is equal to VI plus A delta T. Now they're looking for the initial velocity. What do we know about the velocity at the maximum height? We know that the velocity at the maximum height is 0. And we are looking for the initial velocity. But we chose upward as positive. And we know that our G is always going downwards. And its value is 9.8 meters per second. Therefore, it means that here we must substitute negative 9.8 meters per second squared. And then the time from the point of launch to the maximum height is 1,53. Then you can work out with your calculator, and your initial velocity must be positive because it's going upwards, and you chose upwards as positive. Then we look for the maximum height reached by the ball. If you look for the maximum height reached by the ball, again, you can still use your 1,53 because that talks to the time from the point of launch to the maximum height. Then take the edge of the roof as a reference point. Determine the position of the ball relative to the edge of the roof after 4 seconds. We'll look at that shortly. And then 3.4, will any of the answers 3.2 to 3.3 change if the height of the building is changed to 30 meters? Choose from yes or no and give a reason for your answer. Let's take you through the solutions. Now, the first one is motion of an object under the influence of gravity only. So if the word only is not there, you will not get a mark. So the first one, we were looking at it. Look at gravitational acceleration is negative. So it means upwards is positive here. And then here, gravitational acceleration is positive. It means upwards here was taken as positive. Then we were able to get our initial velocity. So the time 1,53 is only substituted to a point where the time difference between the initial point of launch and the maximum height. And then we want to carry on. Then we go to 3.2.2. So here, 1 mark will be awarded for the formula. But pay attention now to the initial velocity. Initial velocity is positive. So that means this direction is taken upwards, taken as positive, and the G is negative. So gravitational acceleration and the initial velocity, when the object is going upwards, they cannot have the same sign. If the object is going up, the initial velocity and the gravitational acceleration, they cannot have the same sign. That is downwards taken as positive. Still, they have opposite signs because the ball was thrown upwards. So we get the maximum height here. So now, should you get your maximum height as a negative, you need to rewrite it as a positive. That is very, very important. And then the last question, we were calculating the position after 4 seconds. The 4 seconds is substituted here, initial velocity as it is, and the gravitational acceleration and the initial velocity are not having the same sign because the object was thrown upwards. So this is when upwards is taken as positive. So this is when downwards is taken as positive, and the answers, you will see that the answers are the same. So the answer to whether any of them is going to change is no. Why is it no? Motion of the ball is only dependent on the initial velocity, and it does not depend on the height of the building. Thank you very much for watching our lesson. We wish you join us in the next lesson as we continue to revise paper 1 and to prepare for the trial exam. Thank you. See you in the next lesson.